So I'm on Twitter the other day. It was a Thursday. Where's the new Numoku puzzle? There's no new one. Numoku's like Sudoku, but it's smaller. 6 by 6 instead of 9 by 9. I enjoy solving these puzzles, so let's fire up Python and I'll show you how I do it. Give credit where credit is due. Do some imports. Importing time, random. So we have to save our file. We'll also have to choose an interpreter. .8, that'll do it. 3.7. And it works. We have time. So now let's enter the board. I just use periods for the blanks, hard code in the numbers. Now we'll have to create a function so we can convert the spaces into x's. I guess this could be done a little bit differently, but this is the way that I've been doing it, counting the number of blanks. All right, and it prints up okay, but we want it to print up really pretty. So create a printboard function. That'll put them all into rows and columns so that we can take a look at it. Let's create a random board and then see how it prints up. Yeah, there's the first row. Works out. Create the rest of it, doing some copying and pasting. Looks good. Now some functions to save everything that's in a row into a list. So yep, that's row number 1, index 0. Same thing for the column. That's right, that's column number 0. Now we'll do the same thing for the quadrants. Great, so now we'll check that. Is it going to print out quadrant 0? That's right. 368. How about quadrant 3? Yep, 766, 194. Got it. Now we want to be able to go over any of those lists. A row, a column, quadrant, and return true if there's a repeat in any of them. Now the all-important check no conflicts function. This is going to check and make sure that there's no conflicts, no repeats, all the totals are right. And in future Numoku puzzles, when they change the restrictions and restraints, then we'll be able to put new stuff into this function. Now that we're able to check for no conflicts, we can solve the puzzle. Now our solve function is going to put a bunch of random numbers into a list, and then it's going to check the list whether it works in the puzzle or not. Extend solution is where we get some recursion. It's going to solve for a square and then go on to the next square if it's safe. If it's not safe, it'll backtrack and reset the values. Wait for it. There's the recursion. Extend the solution. So finally that should get us to the end of the puzzle. The cryptic if name is main command, it'll run the main function perfectly. No, I have a list index out of range. So what that means is the solution list doesn't have enough elements in it. Well, yeah, of course. I'm just putting in numbers for the solution. I'm not putting in the hard-coded numbers. So my populate board function is going to do that. it again and see if that works. It did not. Still list index out of range. So I've speeded things up quite a bit so that you can see all the debugging that you have to do. Find out if I put this into this function, am I getting out what I'm expecting to get out? And it's still list index out of range. Anyway, it all came down to one character that was wrong. Can you tell what it was? It wasn't in check no conflicts, Pete. Keep looking. No, not there. There it is. It was in the populate board. A J should have been an I, and hey, now it's printing out. In fact, it's printing out too many times, so I'm going to have to take out one of those print statements. Print out all the boards, see it working and backtracking. Even the printout is wrong. I have to populate the board before I print the board. There it is, 46 seconds. I've got the solution. Just for kicks, I'll take out the print the board statement during every single loop and see how long it takes. 12 seconds, much better.